Today we're learning about the greatest common factor and factoring by grouping. We're starting chapter 7, which is all about factoring, different kinds of factoring. Today we're going to be doing the greatest common factor and factor by grouping. So I know I've got this when I can find the greatest common factor of a list of integers, find the greatest common factor of a list of terms, factor out the greatest common factor from a polynomial, and factor a polynomial by grouping. So key vocabulary of factors, factored form, factoring out, greatest common factor, and grouping. When an integer is written as a product of integers, each of the integers in the product is a factor of the original number. When a polynomial is written as a product of polynomials, each of the polynomials in the product is a factor of the original polynomial. Factoring is writing a polynomial as a product of polynomials. The greatest common factor is the largest quantity that is a factor of all the integers or polynomials involved. So finding the greatest common factors of a list of integers, write each number as a product of prime numbers, so the prime factorization, identify the common prime factors, and the product of all common prime factors found in step 2 is the greatest common factor. If there are no common prime factors, the greatest common factor is 1. So out of 12 and 8, this is what they want you to do. They want you to list it like this, and so you see the greatest common factor is 4. Now, in algebra, I feel like most of y'all can go, what is the biggest number that goes into both of those? 4, and get it like that. That's what I usually say. So out of 7 and 20, do those have any common factors? No. So the greatest common factor is 1 because they don't have anything else in common. So you try this, 6, 8, and 46. The greatest common factor is 2, because 2 is the highest number that will go into all of those. And then 144, 256, and 300, the greatest common factor is 4. All right, so now moving on to the algebra side of it, find the greatest common factor of each list of terms. So what you're going to do is out of x cubed and x to the 7, what do they both have in common? They both have at least 3 x's in common. So the greatest common factor is x cubed. So I'll say this. If you got 2 of these, you pick the smallest one basically because they would have only 3 x's in common. Okay, so find the greatest common factor of the following list of terms. So watch, without writing out like they have been, how many a's do they all at least have? They all have at least 2 a's. How many b's do they all at least have? 2 b's. So the greatest common factor is a squared b squared. All right, find the greatest common factor of each list of terms. You go ahead and try this. So it's 2x cubed because 2 is the biggest number that will go into both 6 and 4, and they both have at least 3 x's. The first step in factoring a polynomial is to find the GCF of all its terms. Then we write the polynomial as a product of factoring out the GCF from all the terms. The remaining factors in each term will form a polynomial. So watch. Example 3, factor out the GCF in each of the following polynomials. All right, what is the biggest number that will go into 6, 9, and 12? 3. How many x's do they all have in common at least? They all have at least 1 x. Now, to factor this, I'm going to say, what would I have to multiply to 3x to get 6x cubed? I would have to multiply a 2 and 2 more x's. What do I have to multiply to 3x to get negative 9x squared? I would have to multiply a negative 3 and I need 1 more x. What do I have to multiply to 3x to get 12x? 4. All right, the next one. All right, what do all of those coefficients have in common? They all have at least a 7, right? And then how many x's did they all at least have? 1. How many y's? 1. Now, what's left? What do I multiply to 7xy to get this? So 7xy times what would give me 14x cubed y? I need a 2 and 2 more x's. 7 times 1 is 7. And how many more x's do I need? 1. What do I need to multiply to 7xy to get negative 7xy? A negative 1. So that is my answer. All right. Factor out the GCF in each of the following polynomials. So in this one, what do they have in common? So this is one term and this is another term. So what do those terms both have in common? They both have an x plus 2 in common. What don't they have in common? So you say what's on the outside, which is a 6 minus y. Okay, so what do both of these have in common? This is one and this is one. They have a y plus 1 in common. What don't they have in common? So basically what's on the outside, the xy, and then this minus, there's nothing there, so you assume it's a negative 1. And that is your answer. All right, I want you to do this one. And your answer for the first one and the second one. So let me know if you need help with those. All right, factoring polynomials often involved additional techniques after initially factoring out the GCF. Most of the time it does. One technique is factoring by grouping. So you factor by grouping when you have a 4-term polynomial, also known as a quadrinomial. Quad means 4, so it's a quadrinomial. Group the terms in 2 groups of 2 terms so that each group has its own factor. Factor out the GCF from each group. If there is now a common binomial factor in the groups, factor it out. If not, rearrange the terms and try again. So here we go. So if you have a quadrinomial, so 4 terms, I like to split it in half with a line. What can I take out of the first part? So what can I factor out? What do they have in common? They have a y. If I multiply, like what do I have to multiply to y to get this? I need an x and a 1. What can I take out of this back part? I need to, they both have a 2 in common, so I'd have to multiply an x plus 1 to get 2x plus 2. Now, what do both of these factors have in common? They both have an x plus 1, and what don't they have in common? The y plus 2. So split it in half, pull out the GCF from both halves, and then put your common terms together. All right, let's try again. So factor out each of the following by grouping. Now, what I can just see by this is that this x squared and that 4 have nothing. So I am going to, I'm going to rearrange it. So I'm going to put my 4's together. So I'm going to have x cubed and x squared. I'm going to have 4x and 4 together. So that way I have more like terms together. All right, so I'm going to split that in half. And you can do that because that's a commutative property of addition. So I haven't really changed anything, just the order. All right, so what can I factor out of the first half? They both at least have an x squared. And what do I need to multiply to x squared to get this? An x plus 1. What does 4x and 4 have in common? A positive 4. And if I factor that out, I'm left with x plus 1. So what do those things have in common? The x plus 1. What don't they have in common? The x squared and the 4. And notice my answer is in a different order than theirs. That's okay. It's the same thing because the commutative property of multiplication, it's the same thing. All right, let's try this one. So we've got factor 2x minus 9y plus 18 minus xy by grouping. So again, 2x and 9y have nothing in common, so I'm going to rearrange this. So I'm going to put my x over with the other x. So I've got 2x minus xy minus 9y plus 18. Now I'm going to split that in half. What can I factor out of the first binomial? What do those both have? They both have an x. And then what do I need to multiply to x to get that? 2 minus y. Right? What can I factor out of negative 9y plus 18? I can factor out a negative 9. So this sign always needs to match that sign. Okay, and when I do that, I would be left with y minus 2. Well, what you can see is the 2 minus y and the y minus 2 are opposite of each other. So I can fix that by doing this. So I can change that sign of the 9 and I can rearrange, because this still gives me, look, 9 times 2 still gives me 18, and 9 times negative y still gives me negative 9y. So it's the same, it's just in a different order. So what did both of those have in common? 2 minus y. What do they have not in common? The x plus 9. All right, now you try one. I know the answer's there, but see if you can get it. Pause. And that should be your answer. Okay, here's some extra practice that I want you to try. Go ahead and pause, and then I'll give you the answers in a second. Okay, and these are your final answers. So go ahead and check and let me know if you need any help. All right, so I know I've got this. When I can find the greatest common factor of a list of integers, find the greatest common factor of a list of terms, factor out the greatest common factor from a polynomial, and factor a polynomial by grouping. Do you really understand though? So describe how you would determine the greatest common factor that can be factored from the terms of a polynomial, such as 12a to the 6th plus 8a to the 4th minus 10a cubed. You would find the greatest common factor of the coefficients and the greatest common factor of the variables, which is the variable raised to the least exponent. And that's what I told you before. The greatest common factor is the variable raised to the least exponent that they all have in common. All right, so then factor that out. And you should get 2a cubed times 6a cubed plus 4a minus 5. What greatest common factor can be factored out of the polynomial below? And of course, that would be b minus 1.